recording is start. So basically that class will be totally based on I'm just telling about the very basics, how we are focusing, means how we are designing the entire session. Okay, so that I can discuss first. Okay, so first, if you see that I have already told you. So as I am not recording the previous one, so again some of the portion I'm going to repeat it, that the very basic idea of the power electronics. Okay, so all of you aware about it. Basically, you have already attended the course. Okay, so the course in your maybe fourth or maybe your fourth semester. Am I right? Maybe fourth semester. So you have the basic idea about it. So what is the motivations of the power electronics? Why we are going to be focused about that subject? What is the importance of our real life applications? If you see that lot of applications are there in the renewable integrations, then different power supplies, then inverter applications for machine drives, then cyclo converter also be there for the machine drive. So very basic and very important applications you can observe from the power electronics converters in the different field of electrical engineering, with having the different wide range of rating. Okay, from sometimes from very fraction of watt to up to some megawatt range. Okay, like your fax device. Okay, that is in your megawatt range. Okay, so that you can that you can see from there. Okay, so we can we can more focused, we should more focused about the different in these subjects. Actually in this laboratory, so we are more focused about the simulations. Okay, simulation study of different power electronics converters, starting with the rectifier, means uncontrolled rectifier, up to cyclo converter, inverter, that we can go maximum how much we can cover with the given time period. Okay, that for this semester I think the time period is reduced to maybe 65 classes like that. Okay, so we have to complete everything within the given time period. Okay, so normally we have planned for nearer to the 10 experiments. If you know that you have attended my previous classes, means previous classes as well as previous laboratories. Okay, so like your network laboratory, so we know that one we have to follow the some of the standard methodology for the laboratory classes. Okay, so there are different in that laboratory there are different segments. Okay, there are different segments of the classes. Okay, so from the most cases you can see that every day you have to will provide you the lab material. Okay, means you know that one will provide you the the manual. Okay, manual that will be provided by your another sir, that is Ramaprasad sir, that he will provide you every day to day. So you have to simulate. First you know the basic concept of that like you can take an example. Okay, so the simulation of uncontrolled rectifier. Okay, so it may be half wave rectifier, it may be the full wave rectifier. Okay, only the diode bridge rectifier. So you know that is very famous in our analog electronics also, but in power electronics the devices are quite different. Okay, in analog electronics there is a huge differences between the analog electronics and power electronics. First difference is that the range doping. Okay, the doping of that analog electronics devices are different with rest compared to the power electronics. You can say like that the doping of the power electronics converter means switches or the devices are different with the analog electronics. Okay, basically the power range is very high. Okay, some cases very high in the power electronics converter. So power electronics devices, that's why dopings are different. Okay, so if you see the basic structure of the analog diode, okay, and the power diode, you can see the differences. Make a Google search, you can see that what is the difference, means structural differences between the analog diode, analog electron, like you know the number of the analog analog diode like 1N4007. Okay, means it's only 7 volt diode. Okay, another one is MUR460 diode, that is power diode. MUR460 means 60 means it is nearer to take the voltage around 600 volt, and 460 हाँ हाँ आप जाइए, आई विल इंट्रोड्यूस। ओके, आप ऑनलाइन हो जाइए, ठीक है ठीक है। मैनुअल का जरूरत है? हाँ 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 ले आओ आपके पास। हाँ जस्ट रिकॉर्डिंग, जस्ट फॉर अ मोमेंट। ओके प्लीज, आपके पास ये है मीन्स सॉफ्ट कॉपी मैनुअल का चेक करो। अच्छा अच्छा, तो आप अभी एक बट इन लोगों को तो सॉफ्ट कॉपी देना है ना, फोटो खींच के देना है, नहीं तो स्कैन करके देना है। तो स्कैन करके फोटो निकाल के देना है। फिर आज के लिए ये करते हैं, देन इन बिटवीन कुछ कैन स्कैनर में लाइव में दे दो। कौन सा बुक है ये? आज S1 लिखा है, S1 अंडरस्कोर पावर लिखा है, देखिए कल क्रिएट किए हैं, अभी चल रहा है, देखिए आपको भी शायद चल रहा है। हाँ हाँ, आप ओपन कीजिए, देन आप कुछ बता दीजिए कैसे कैसे होगा ये। मैं एक बार बोल रहा हूँ, जो स्टूडेंट के सामने नहीं बता रहा हूँ, हाँ जो स्टूडेंट का ऑनलाइन नहीं बोल पाएंगे उसको मैं फोटो बता दूँ। ठीक 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 है, ओके। अच्छा, मैं अटेंडेंस ले लिए, आपको शीट दे देंगे। ठीक ठीक। Okay, so so different where was I? So different topologies. First, difference between the analog means analog diode and the power diode. So that is analog diode 1N4007 and power diode is mood diode. Okay, so as per the serial number you can understand. Okay, the serial number of the diode, the rating of the diode you can understand. Okay, for any of the devices, analog as well as power. So you know the structural difference as well as the doping ratio difference. Okay, a lot of differences are there for tolerating a huge range of voltage current. Okay, so first we have started with that uncontrolled rectifier. Okay, then half wave, then full wave. After that we can go for that control rectifier. Okay, in case of control there are division between semi control as well as full control. In semi control again symmetrical, asymmetrical. Okay, and full wave control, full control means you know that one, that bridge type. Okay, so there are different configurations of the full control. Okay, so you are using only one switch. Okay, one switch with full control rectifier. Okay, you are using the multiple devices. In that case you are also getting the full control. Okay, after that we can go for the different switching converters. Okay, like DC. First we have started with rectifier, means it's a conversion of AC to DC conversion. Okay, normally in power electronics converter, what type of conversions are available? Normally 4 types of conversions are available. First is your, as per the applications. Okay, applications of your devices and the sources are available. Sources means what type of sources are available in your system. Okay, so means what type of sources available is with you. Okay, so there are first AC to DC conversions. Okay, means AC DC rectifier, it is known as rectifier. Then DC DC conversion. AC DC rectifier means your sources are in AC and load are in DC. That's why AC to DC conversion. Then DC to DC conversion means your source is DC as well as load is also in DC. Okay. Then DC AC conversion, that means it's an inverter. Okay, so your source is DC and load also in your AC. Okay, so in case of another one is AC conversion, that is Cyclo Converter. Source is AC as well as load is also AC. Okay, so 4 type of power electronic converters are available. Okay, so as per your availability of the source and the requirement of the nature of the load. Okay, which type of loads are required? Okay, AC type load or DC type load? Okay, so first we have started with AC-DC conversion, means your rectified conversion. So first started with uncontrolled rectifier, then controlled rectifier. Okay, in uncontrolled rectified you are using only diode with. Okay, you are using only diode. Okay, and controlled rectifier you can use any of the thing. You may use for SCR, you may use for MOSFET, you may use for IGBT, whatever. What is your requirement? Okay, so any of the arbitrarily you cannot select the switches. Okay, arbitrarily you should not select the switch. So definitely there must be some requirement why you are choosing the MOSFET, why you are choosing the IGBT, what is the motivation for choosing the devices. Okay, so how do you understand? So you know that MOSFET is the voltage control device. Okay, so in from very basics of the analog electronics, MOSFET is the voltage control device. Okay, means field effective transistor, no? So it will control by the field. So current strength of the MOSFET switches are not, or should be very less. Okay, and BJT, and you can say like that, bipolar junction, right? So transistor. Okay, BJT, it is a current control, it is a current control device, so current strength should be very high. Okay, so in the application field, okay, so you need to check it. So is it voltage is required or current strength is required? So there is some advantages as well as some disadvantages for your voltage control switches and current control switches. Both having some advantages and disadvantages. Okay, so which one is available with you? Okay, if the current control device is there, so you can use directly diode, BJT. Okay, and IGBT is the combinations of your BJT and your MOSFET. Okay, but sometimes what happen, the switching frequency, okay, the switching frequency is very high, sometimes is required. Why it is required? For the power supply, especially in case of power supply, it is observed that switching frequency is very high required. Why it is required? Basically for reducing the ripple frequency. You know that ripple frequency means performance index of the different power electronics converters. Okay, like your ripple frequency, form factor, peak factor, then crest factor, different factors are there. Okay, so there is a ripple frequency, also very important thing. So if you increase the switching frequency, so what happened, the ripple, okay, converter ripple will be reduced. Okay, so that's why you say like the ripple factor. Okay, so that ripple frequency also very high. If the ripple frequency is high, so it will be look like a more or less smooth, like your DC. Okay, so like your DC signal. So that's why sometimes we have to go for high frequency range. So in that case, which type of converters are familiar with this application? You know that MOSFET. Okay, MOSFET can go up to 500 kilohertz. Okay, as per the changing of the rating. Okay, but in IGBT, normally using for the inverter circuits. Okay, but it having the current state, good current state, as well as some voltage strength. Okay, but it cannot go, the switching frequency cannot go up to the range of MOSFET. Okay, maybe nearer to the 500 kilohertz, but it is not going up to that mark. Okay, so availability of the devices. Okay, so where we are using the current control devices means the amplifications, more of the amplifications are required. Okay, in that case you are using that BJT. Okay, means amplifications means there are different configuration, totem pole configuration. Okay, then another configuration was there. Okay, so that is not, so different amplifying configurations are there. Okay, and Darlington and totem pole configuration. Okay, so two of the, you know that two are the very famous configurations. Okay, so now you have to design the devices. So first starting with the uncontrolled rectified, then controlled rectified, then we can go for DC-DC conversions. Okay, DC-DC conversion means you have to think about your DC-DC converter, means it's known as chopper. Okay, so chopper is there, means again it having different topologies. Okay, like your buck topology. Okay, then boost topology, then buck boost topology, then choke topology, sepik topology, jita topology. Okay, you know that different topologies are there. So again, which one you have to be chosen? Okay, that also depends upon your applications. Okay, which application you are going to be given your trust. Okay, as per the application you have to choose that topology of the converter. Okay, so then DC-DC converter, after that you go for that inverter circuit, means AC DC-AC configuration. DC-AC configure means converter. Okay, so in case of inverter, you know that one you know that inverter means your sources are in DC and you are getting the output as a AC. Okay, again in case of inverter, you know that there are two types of inverter: voltage source inverter, then current source inverter. Again, some types of inverters are there, that is called multi-level inverter. Okay, so multi-level inverter means what? You know that if you see the signal, if you see the output of the inverter, okay, so normally it is coming, the nature of the output voltage is, it is alternating current in nature, but it's look like a square wave type. Okay, so square wave type waveform you can see. So square wave means, again there is a problem of you have to calculate the fundamental one. Okay, fundamental component like your FFT, means Fourier analysis. Okay, so from doing the Fourier analysis, what happened if it is square wave? So definitely there is a generation, there is a presence of harmonics. Okay, so you have to remove that harmonics. But how do you remove that harmonics? So you need to change the topology of the inverter. So which type of topology you are going to be introduced? That is your multi-level converter. Means, so you are using, one thing that is also known as sinusoidal inverter. Okay, sine wave inverter, that is also famous in our domestic application. So you know that one sine wave inverters we are using. Okay, basically initially what happened, that inverter waveform, that outcome of the inverter waveform is not like properly sinusoidal. So and I am telling about 10 years back. Okay, so 10 years back, if you see, when that current is on the load setting condition, if that you can observe that you can see, you can if you can observe that for the normal inverter in the load setting condition, you can hear the humming sound in your fan. Means fan means it's a single phase induction motor, no? So in our domestic fan, okay, means rooftop fan, so you can see that if suddenly load setting is there, so then it will be changing from normal condition to the inverter line. Okay, the changeover switch is there. Okay, so then you can heard about that. Then you can heard about that humming sound in the fan. Then also right now we are using the ballast circuit, na, for our circuit for our fluorescent lamp, means for our illumination purpose. Okay, initially that day we are using some choke coil, na. There is a coil in choke coils for developing the high voltage, for breaking the air column in between the fluorescent lamp tube. Okay, so where you can see that you can understand that if you can able to listen that humming sound. Okay, due to the generations of that harmonics. Okay, as your inverter was not properly sinusoidal, the outcome of the inverter was not properly sinusoidal. That's why what you need to do, you have to design some of the filter. Okay, so you can go for that filter, but a huge range of application, means large vehicles, sorry, large application areas. So what you need to do in that case, the filter designing sometimes quite difficult. That's why filter must be there. Okay, but you have to improvise the topology of that inverter. So you have to go for that multi-level inverter. Okay, so multi-level inverter, maybe 3 level, 5 level, 7 level. Now there's a lot of research is going on up to increasing the length, means number of the level. Okay, for getting the more getting the accurate sinusoidal waveform as an outcome from the inverter. Okay, so that you can also use for different induction motor drives. Okay, different machine drives applications. Okay, so that there is also simulations of your inverter. Okay, then we can finally what is the difference between then what happened in the inverter, you can change the frequency as well as voltage. Okay, in case of inverter. Okay, means your input is DC, but you can change the frequency of output as well as the as well as your sorry as well as your frequency. Okay, as per your application range. then we can go for the cyclo converter. Okay, so cyclo converter means availability of the sources is AC, and as well as the availability of the outcome means output is also been AC. Okay, like in that case you can, it is also applicable for the machine drive applications. Okay, high power machine drive applications, so we are using the cyclo converter. Okay, so again in that case you are changing, you are able to change the voltage magnitude as well as the frequency magnitude. Okay, so I think you get the very brief idea about what you need to do in your simulation lab of power electronics converter. So you have to simulate the very basic converters of very basic power electronics converters that you have already covered in your syllabus. Okay, so one by one it will become so that sometimes that manual means material means your laboratory report. So that is about our theory. Okay, about our idea how do you going to be design our courses. Okay, about your the different experiment title. Okay, so means experiment title, or you can say in a very brief manner means what you need to do for this laboratory purpose, means what you need to simulate here, that I have been discussed. Now we can go for the methodology. Okay, what are the methodology to perform this lab? Okay, you know that we are interacting, that you and me, that all the students and the concerned faculty and the concerned teacher is interacting through the virtual mode. Okay, so you have to be very loyal. Okay, so both of the sides, so you have to be very loyal. Okay, so otherwise what happen, it's about the ethical issues, no? So end of the day, you are in almost complete of your going to be complete of your four final semester, no? So means you are in 8 semester. So enter the nation. Okay, enter the nation totally depends upon our ethical issues. Okay, means after few days, next year maybe this time you will be a successful professional. Okay, you will be attached with a company, or you will be attached with a PSU. Okay, so the major concept is the ethical issue. So we can think that that is in technical point of view, you can say like the reliability. Okay, so you know that in power system concept, the reliability, what do you mean by the reliability of the relays? Okay, means backup system. Okay, backup system is how much reliable. Okay, so if suddenly power is not there, so your backup system is how much reliable. Okay, the reliability of the system. So again, we can, I know you very well. Okay, so last 3 years. Okay, so I know that you are very sincere, most of you are very sincere and very reliable. Okay, so in that case I can think that all of you do your assignment by yourself without consulting with your friends. Okay, without, it is your business, it is your development. So definitely we are in professional background, we need to help, we are believing in the teamwork definitely, but in the case of examination we should not believe our teamwork. Okay, so it is there, so that means that there will be no meaning of that examination. Okay, so I can that I have some confidence about it. So still I am telling in these points, basically that is my duty to let everybody know to you have to maintain the normal ethics. Okay, so do not pass your simulation with your friend. Definitely you can pass it after the examination, but try to that is your responsibility also. So all the students should learn properly. Okay, so that you are doing in the physical mode means you are doing in individual computer. Okay, and individually you are submitting that material day to day. That I am also expecting from your side, that day to day you have to submit without consulting with your friend. Okay, so you should send the material to our concerned technical assistant sir, that means Ramaprasad Samantrayan sir. So day to day you have to after completion of your simulation, so he will give you some of the deadlines, so he must collect it and he'll compile it. Okay, so your duty should be compiling every the material. So what happens, so compiling material, then there is some marks on it. Okay, like that class performance, okay, then viva, then class performance as well as viva. Okay, so that all are just a moment. So the so that all are there, na? So day to day you have to submit. Okay, you have to submit, you have to first you have to simulate that one, then you need to submit it. So we are also conducting one test. Okay, day to day means every day we are planning to take some test. Okay, so that will helpful means like your viva was. Okay, so that relevant of your experiments, relevant of your simulations as well as theory. So maybe 10 marks test for 5 minutes, only for 5 minutes. So MCQ type through the Google form mode. Okay, so you have to give the test. Okay, so you will get some marks on it, so that marks will be documented over there. So in that case, again I need to see that you need not to consult with your friend for giving the test. Basically we don't have any option, so we have to believe our students blindly. Okay, that's why I am telling about that ethical issues. Okay, so you should maintain the professional ethics. After few days you will be a successful professional, so we should not violate any kinds of professional ethics. Okay, that is my suggestions, that is my request to all of you. Okay, so there is some segment. So first you need to do the simulation, then you need to do the prepare your manual, means your own means documentations for individual experiment. Then you have to submit it, and then the test will be conducted. Okay, and you have to give the test for maximum 3 to 5 minutes you have to give in. Okay, 3 to 5 minutes, or the question will be 10 MCQ. Okay, so you have to give in the test, and that marks every day, that marks will be collected and it will be compiled. Okay, end of the semester it will be important for your gradation. So that's the basic way. Okay, then at the time of after completion of your means after completion of your laboratory, there will be test. Okay, so final test on it, so that one, so you have to submit the final version of your document, means laboratory assignments. Okay, laboratory assignments, and the test will be there. Okay, it may be viva voce or it may be written test, like that, means it was there na, in network lab. Okay, so that method also being followed. Okay, so I think you are able to understand that way. So now I am requesting Ramaprasad da, please tell something to our students. Okay, Ramaprasad da, am I
Yes, sir.
audible from your side?
Yes, sir. Yes. Good
Okay,
morning.
good morning, Ramaprasad da. Okay, tell
Good
me.
morning.
Tell.
So, good morning, all of you. In this lab, we'll conduct up to 10 experiments. And the experiments will be simulated using multisim software. Some of the experiments you have to perform using multisim software and MATLAB simulating software. Okay. So सर आप दे दिए हैं जो मैनुअल्स मींस लिस्ट ऑफ द एक्सपेरिमेंट दे दिए हैं. हेलो सर. हेलो. ओके, तो ठीक है, मैं बोल देता हूँ यहाँ पे क्या क्या एक्सपेरिमेंट परफॉर्म करना होगा. सो फर्स्ट एक्सपेरिमेंट इज एनालिसिस
Oh,
ऑफ.
sorry. Hello,
ओके
am I
ओके ओके
audible,
सर.
Ramaprasad da?
यस सर,
Okay,
यस सर.
sorry. My microphone was muted. Okay, so no, sir, I didn't give them the name of the experiments. Okay, so if you have it with you, so you can tell the name, so all the students can note it down. Okay.
ओके ओके सर. सर सर आई एम
So you
टेलिंग द
can
नेम्स यूजिंग
you
द.
can tell the name, or you can just read out the name of the experiment, so they can note it down, and day to day they can prepare on it. So before
ओके
starting, before coming to the lab, okay, all of you
Okay.
are requested, please go through about your topic. Okay, then you can understand very well. Okay,
Yes.
Ramaprasad,
Yes.
please. Yes.
Sir, I'm telling the list of the experiments.
Yes.
Please check it whether any correction is required. You please modify.
Sure,
Huh?
sure, sure, sure,
So
sure.
first experiment is analysis of single phase half wave diode rectifier and thyristor rectifier with various loads.
Okay, all of you please note it down. The name of the first experiment.
Analysis of single phase half wave diode rectifier and thyristor rectifier with various loads: R load, RL load, RL load with fueling diode, L load with freewheeling diode, RLE load. Okay.
Sir,
Yes.
sir, won't it be better if you share the manual in the group or class
Actually,
materials?
yes, yes, definitely we will send everything. But just you remember the list of the experiments. If possible, you write it.
Okay, sir.
For your information, you write it what experiment you have to perform. Okay. So we
Okay, sir.
will share everything. Don't be worried about
Day to day
the.
it will be shared. Meenakshi, day to day, sir will be shared everything. Okay.
Yes, yes.
Okay, sir.
Please note it down
So
right now.
Yes, sir.
I
Yes, sir.
was in leave. That's why I have not prepared the list in a Word file. I will next class, not next class. In free time, I will take the CR contact number and I will share the list of the experiments. Okay. Hello.
Yes, sir. No problem. Okay.
Hello, sir. Good
Yes.
morning, sir. Sir, sorry to interrupt. Sir, I was having some issue while joining MS Team. Now I have joined.
Okay.
Okay, Vishwajit, no problem.
Okay.
Okay.
I just take your attendance. Note it down. No problem. Okay.
Okay.
You
Okay,
just
sir.
note it down. The entire session is recording. I have also posted to your group. Okay, please. I'm just suggesting Soumitra for your group means S1 group. Please make a WhatsApp group also. Okay. I just posted that video link to the
Yes.
WhatsApp
Yes.
group.
Yes.
Okay.
Yes. Yes. That will be
So
better.
I just yes, I just downloaded and posted it to the WhatsApp group as well as MS Team. Okay. So Soumitra, please prepare a WhatsApp group. Okay, among your students for the S1 and also require also tell that Rahul Shamal means Rahul to make another group for S2. Okay. Okay.
So first experiment, that is analysis of single phase half wave diode rectifier and thyristor rectifier with various loads using R load, RL load, RL load with freewheeling diode, L load with freewheeling diode, and RLE load. Okay. And in same experiment, you have to show the waveforms of current, load current, source current, output voltage, diode current, etc. So during explanation, we will explain everything. Okay. Next, experiment number 2, to analyze and study the waveforms obtained from controlled half wave rectifier, with source voltage we have given, that is 230 volt 50 hertz. To observe the characteristics, 230 volt 50 hertz, to observe the characteristics by varying the load inductance. The characteristics are load current, source current, load voltage. Okay. Again, I'm telling the experiment number 2, to analyze and study the waveforms obtained from controlled half wave rectifier. You write it, controlled half wave rectifier with supply voltage 230 volt 50 hertz to obtain the characteristics of load current, source current, load voltage by varying the load inductance. Okay. Next, experiment number 3. To analyze and study the waveforms obtained from single phase fully controlled full wave converter. Write down. Study of single phase fully controlled full wave converter with source voltage 230 volt 50 hertz and to observe the characteristics of load current, source current and load voltage by varying the extinction angle. This is experiment number 3. Okay. Next is experiment number 4. To study and simulate single phase full wave controlled rectifier with one thyristor open, short and using one diode in place of thyristor, open thyristor for various loads. That is R load and RL load. Again I'm telling, study and simulate full wave controlled rectifier with one thyristor open circuited, then short and using one diode in place of open circuited thyristor for various loads. Okay. This experiment you have to perform using freewheeling diode and also without freewheeling diode. Okay. So okay. Next experiment, experiment number 5. To study and simulate 3-phase full wave uncontrolled bridge rectifier. To study and simulate 3-phase full wave uncontrolled bridge rectifier and semi-controlled bridge rectifier for various load. Various load means for R load, RL load and RLE load. Okay. Again I'm telling, to study and simulate 3-phase full wave uncontrolled rectifier and semi-controlled bridge rectifier. Uncontrolled bridge rectifier and semi-controlled bridge rectifier using R load, RL load and RLE load. Okay. Then experiment number 6. Sir, are you observing these experiment names?
Yes, sir.
Okay. Then experiment number 6. Study of operation of 3-phase full wave controlled converter. 3-phase full wave controlled converter with different loads and with different firing angles. using freewheeling diode and varying inductance values. Again, I am telling, study and operation of three-phase full wave controlled converter with different loads, with different firing angles, and also using freewheeling diode by varying various inductance values. Okay. Achha. Next, experiment number 7. Write down. Experiment number 7. Hello. Okay. Experiment number 7. Simulation of buck converter. Simulation of buck converter. Simulation of buck converter. That parameter you have to give according to manual. You have to give 12-volt DC source and your supply frequency 25 kilohertz. Then you have to simulate buck converter. Okay. Next, experiment number 8. Simulation of boost converter. Study and simulation of boost converter. Okay. Simulation of boost converter. Next is experiment number 9. Experiment number 9. To design and simulate single pulse and sinusoidal PWM inverter with different duty. To design and simulate single pulse and sinusoidal PWM inverter with different duty. Experiment number 10. To study single phase full bridge inverter and PWM generator. To study single phase full bridge inverter and PWM generator. Last experiment, experiment number 11. To model a DC motor in Simulink and observe various waveforms. Okay. So these are the experiments you have to perform in this lab. So actually, students, if this kind of condition will not happen, then strictly we are taking the lab as we have done last 7 years. I have joined in this institute, and in this lab I am remaining last 7 years. So what are the conditions? Means first you have to simulate yourself. First you have to prepare yourself. First you have to prepare yourself about the theory. What are the theory of the concerned experiment? Then during simulation you can take help of me, sir, and also from your friends. Okay, or TAs, how to simulate. Then know the waveform. What waveform you are plotting, you should know. You don't copy from others. If blindly you will take the waveform from others, then during viva means you will be evaluated wrong. So that's why sir already told you everything. So as this online class is going on, it is difficult for us to evaluate all the students, because in hardware lab means physical laboratories, we are seeing the students how they are doing the simulation. But in this case we are not means we are not getting your performance as this is a virtual lab. So uh, try to build your career yourself. Don't copy from others, because anything you will do wrong, it will be reflected in your future classes. So that you should take the lab improvements seriously. Okay, so whatever the simulation you are doing, if you copy some other from other students, then you definitely will catch them, because your circuit, on the basis of your circuit diagram and circuit parameters, your waveform will come. Okay, suppose in circuit diagram we have written 3 millihenry inductance value, and in your waveform it is showing some different values, means output should be 5 volt or 6 volt, it is showing as per your circuit diagram, and in output result it is showing 9 volt. But other students they are showing exact value. That means you have copied from others. So that's why we are telling, whatever the circuit you are simulating, on the basis of your circuit parameters, your time, whatever the time period have given, or frequency have given, whatever the source voltage is given, so on the basis of that, whatever the value of inductance, capacitance, resistance, whatever the means, whatever the value are editing, on the basis of that your waveform will come. So don't be means don't blindly paste any waveform without any simulation. Okay, so take the lab seriously, huh? So this is one message from me to you, and I hope uh, you all will do better, and my wishes for all to get good, means good grades, huh? For means good score. Okay, so these are the labs you have to perform in this. These are the experiment you have to perform in this lab. So everything I will send you. I will send to sir. Sir will send to the CR. Then, as per the experiment list, your experiment will be means you have to perform the experiments. Okay. हेलो.
हाँ हेलो.
हाँ सर. सर बोलिए,
हाँ
और कुछ है तो ठीक है, एक्सपेरिमेंट जो है, या कुछ एडिट करेंगे?
हाँ, is it okay? If is there any modification, am I audible? No. If any,
Yes
is
sir,
there
yes.
any modification? So we can modify after
Be-
means after the
before
duration of
before
that exercise.
before one
Yes.
experiment we will tell to students whatever
Yes.
the
Yes.
modification.
Is there
One
any
lab before,
modification we can provide?
one lab
Okay.
before we will tell you.
Ha 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 ha. So today, Acha, just student, all of you, please wait. Okay, just wait. Just wait for a moment. I just talk to Rama Prasad, sir. Just wait. All the students. So dear, also today we are not planning to start the experiment. So on the next day onwards, the experiment will be the next day onwards. The experiment will be started. Okay, so we will provide you the manual. Okay, we will provide you the manual before starting of your lab class. Okay, so you have that name of the experiment with you. So my suggestion is to you should prepare, means at least the theory in any of the standard books. You can follow Rashid. Okay, you can follow the book of Professor Rashid. Then you can also follow the book of Ned Mohan. You know that another book also be there. That is your Erickson book. Okay, this any of the book, any of the, you can follow the name. I'm telling you three names of the author. Okay, of the power electronics book. Okay, you can follow any of them. Okay, so before starting, my suggestion is to, before starting the lab, so you must prepare yourself and please try to attend it, and day to day we'll take that exam na? So that's why I'm telling you. Okay, so you should prepare before coming to the lab. Okay, so next day onward it will be started. So I think this is enough for today. So again I'm taking some asking for the attendance for asking for the attendance for some students. Those are not responded, taking the attendance. That roll number 342 Vishwajit, is he present?
Yes, sir. Yes, sir. I'm present.
Okay, thank you. Also, I'll post it to your group. That video, Soumitra have already formed the WhatsApp group. I just post that video to there. So all of you, please, if you have missed anything about the title of the name of the experiment, you can see from there. Okay. So
Sir,
thank
one
you.
minute, just
Yes.
1 minute.
Yes.
Sir, can I have mobile number of CR?
Yes, I'll provide you. I'll provide you the
Okay,
phone number of Soumitra. Okay. I'll
okay,
share with you through WhatsApp. Okay. You
okay.
can also, I can also, okay. So if possible, you please add Rama Prasad ji in the WhatsApp group also. So he can get the intimation from student side as well as my side. Okay. So I'll provide you the number, both means here as well as here. Okay, to the Soumitra and Soumitra's number to you also. So you please means you can add him. Okay, Soumitra. Okay. So can we okay, so thank you. I just stop my recording session. Okay, so another